Hello and welcome to another video. So on the bench today is the Marshall Origin 20, and this is the one that we looked at about 13 months ago, and it's back. I've run this amp up because apparently it's on for about 30 minutes and then it begins to start to break up and cut out, which is exactly what it's doing. I had it on test for an hour or so and then put a guitar through it and it was terrible. So we need to get it out of the case and have a look, look at the board, see if we can sort this one out. And this is an ongoing problem with these type of PC board amps. PC board extravaganzas, I call them. It just seems to be an ongoing problem with them. You'll have to excuse my voice, by the way. If I sound a bit nasally and sniffly, I've got a bit of a cold. Well, I've got a lot of a cold, really. Right, so if we I've got the back off, and if we look in here, you can see this Celestion speaker that we've got in here, which is a G10 Gold, 16 ohms. We'll just have a quick look at the front. So we've got the gain, control, tilt, which is some kind of, don't know what that is, some kind of it's a presence or whatever. We've got a presence here, so I don't know, so it must be some kind of EQ sweep or something like that. We've got bass, middle, treble, master volume and presence there. And it's also got, if I just hone the camera in a bit there, you can see it's got the low, high and mid. So it's high output, mid output and low output. Don't really know how that works without looking at the schematic, whether it's a power scaling device or what. Now, the one thing to notice with these transformers on this amp is that they're quite small, and in actual fact, if you look at the power transformer and the output transformer, there's really not that much difference between them. One of the problems with this transformer is it does get really hot, and if you look at that transformer and then you look at what tubes are in this amplifier, they are EL34s, what's being run by that little transformer. So although this amp's only 20 watts, it's drawing a fair bit of current. And there is a model number on that transformer, but nothing about how many milliamps it's capable of taking. So we've just got three 12AX7s in there, just as normal. So what we're going to do now is we're going to put some power on this amp. I've raised this amp up now so we can have a look inside, and you can get a real look at these PC boards. So you can see we've got these radial capacitors here, electrolytics, and if we look at that one there, you can see, can you just see that there, as the glue's already cracked on that, that's the constant heating up and cooling down process of these boards. And this transformer, this power transformer, is not far away on this side, and you can see that's getting extremely hot. So that one also is now loose. These two are fairly, so those two need a coat of looking at. Let's have a look. And the other thing to look for on these is if these tops are bulged on any of these caps. I wouldn't have thought on this amp, because I wouldn't have thought it's that old really. So we're going to switch it on and see if anything happens. So we need a chopstick of some description or something we can probe with, and this will do nicely. So we just need to put some glue around these here. Let's just have a look and get over the top so you can see a bit better. There we go. See, the problem with this is this fault only occurs when this amplifier gets hot, And the problem is, now I've taken it out of the cabinet, it's getting plenty of air to it. So unless it's the transformer when it reaches a certain temperature that's becoming intermittent, i.e. the output transformer, or these tube sockets, one thing I did check was the send and return socket on the back. The send and return sockets, but they don't cut out like some of them used to, where you plugged into the send and it would cut out the signal, and then you would plug the lead into the return and the other end of the lead and it'd come on again. And those used to get the contacts used to get dirty, and they used to just put a lead in to link them up, but I've checked that, so that's not the problem. Microphonic that tube. Oh. Oh, look at that. Oh. Aha, it's the old just see if we can get in and have a close look at that. Just hone in. So this is what we're looking at there. Is this here. And it looks to me, well, that might not be the problem, but it's certainly one problem with this amp. Right, I better have a look at that. Right, that seems to have cured that. So what's happened there? The plug, the pin inside the plug, has come off the terminal. So what happens with this is the amplifier's being played, you know, the guys using this at his rehearsals or whatever. The vibration, as this amp gets warmer and warmer, these pins get looser and looser, and with the excessive heat, this is why it probably takes a bit of time, and then it gradually just vibrates up, and it probably has done that over a period of time, just gradually worked its way out the plastic plug thing. So yes, so I think we might have to take that plug off and tighten up those pins, and then maybe put a smidgen of hot glue over those, just a smear of hot glue, just to make sure they don't come out again. That's really the only way we're going to be able to cure that. That may just be the only problem with this amp, but we'll check round, we'll carry on checking round, because you just never know, we might find something else. And we've got to put some hot glue on these. We need to just make sure they stay stable. Poor design. It's a shame as well, you know, some of these amps don't sound half bad, but the way that they're put together, these plugs for instance, you know, I'm sure they could find a bit better plug than this. You know, we accept the fact that we've got PC board amps nowadays, but cheap plugs on there, come on Marshall, you can put some decent plugs on. These things are rubbish. Right, I thought I'd just do a bit of a check on the bias on this amp, just to find out what current is being drawn with those EL34s and just how they are set up. Let me just turn this volume down a bit. This is the cathode resistor here, and this amp is cathode biased, so 150 ohms. The drop across that resistor is 16 volts. So if that's 16 divided by 150 ohms equals 106 milliamps. If we divide that by 2, that's 53 milliamps. So we've got 106 milliamps draw on that transformer. 53.3 per tube. Now if we take away 5% for the screens, that'll give us a more accurate dissipation. That leaves us 50.6 milliamps, so 50 milliamps virtually. If we're only doing this rough, aren't we? We're not doing it, we're not down to the wire. So the voltage drop across the plate to cathode, sorry, the voltage from plate to cathode is 248 volts, and if I times that, 248 equals, that's, so they're biased at 12.5 watts each. 12.5 watts each. I don't, it must be me, and there's some guys on, you know, on that subscribe to my channel that are far better techs than I am, with much more knowledge. But tell me why you would use two L34s in a 20 watt amplifier that in total are drawing 106 milliamps on a transformer the size of a farthing, when you could put a couple of 6v6s in there or a couple of EL84s. You could, the voltage, you'd have more voltage going across those because you'd have less current, as opposed to the current we've got now. Drawing that down to 248, you would probably have nearly 300 volts with a couple of 6v6s, and this amp would sound just as good. What I can't understand, at 12.5 watts with 248 volts, why this amp's not in crossover distortion. I don't really understand why. That seems madness to me. This amp, you know, when it's been in its case for a while, the amount of heat it's generating, this transformer is already hot, and this amp is running on my bench with plenty of air around it, and it's already getting to the point where it's hot. Another 30 minutes to an hour and that will be red hot. I don't know, but whoever's designed this has obviously got 20 times much more knowledge than I'll ever have when it comes to amplifier design. But nonetheless, I'm left scratching my head on this whole design. If you'd put a pair of 6v6s in this, it would have run cooler. You would still probably have near enough the same output. You know, you can bias a couple of 6v6s at 12 watts. These are only at 12.5. You can bias at 100% with cathode bias. You could have put some 6v6 S's in there and got 14 watts a side out of those, and got the same. You'd have got the same power out of this amplifier, I'm sure, with a lot less heat, a lot less current draw on that transformer. It bemuses me why. In fact, I think if this was mine, I think I would put a couple of 6v6s in this and bias it. Of course, the only problem with that is then really you need to do a turns ratio test on the transformer to make sure you match the effective load resistance up if you was changing the tubes to that degree. And of course, it's a PC board. You would also have to check that there's been no magical wiring on those tube bases. The filaments would be the same. But I think that's what I would, if this was mine, and I think that's what I would be inclined to do. Maybe one day we'll get one of these in, and maybe we can experiment on it, who knows. But we're certainly not going to do that on this one because it's the customer's amp. The hot glue gun has warmed up, so I'm going to just put some glue over that, around those caps and over that plug, and we'll put this back together and run it up for 30 minutes, and then what I'll do is put the guitar through it and we'll have a listen. Right, we've got this Origin 20 all buttoned up, and we're going to have a bit of a listen. controls there. So yeah, so that you can't get a deal of overdrive out of these amps. So this tilt control that's on it, it's just like another treble control really. So there we have it. That is the Marshall Origin 20 that came in for dry joints, or double digents as I like to call it. We seem to have got to the bottom of it. Looks like it was that plug that was on there. It's not made a murmur since. It's been perfect, so I think we're going to be okay with that now. So that'll do it for this one. Thanks for watching, and you all take care, and I'll see you all in the next video. Bye bye for now.